Welcome to Brain Vision.
We have two tubes. They have an equal number of molecules with the same sequence. One tube has single-stranded DNA. The other tube has RNA. And this is just going to be single-stranded. Usually RNA is. You'll probably be told if it's double-stranded. So they have the same number of molecules. Which one has greater mass? Well, we need to know which individual molecule has greater mass, the piece of DNA or the piece of RNA. So what's the differences between DNA and RNA? Well, the first one, which doesn't apply here, is uracil versus thymine. So DNA has thymine, RNA has uracil. Doesn't apply here because the sequence we've been given doesn't have either, so we don't have to worry about this difference. Instead, we worry about the second difference in the fundamental structure, and this is in the backbone, and it is ribose in RNA, deoxyribose in DNA. So this is talking about the pentose sugar. So if we draw a nucleotide, they both have a phosphate group in each nucleotide, and then they have this 5-carbon or pentose sugar. And then they have the nitrogenous base coming up here. So what's the difference between ribose and deoxyribose? They each have several hydroxyl groups, but they differ down here. This is the second carbon. This is carbon 1, 2, 3, 4, and 5. And on the second carbon, in ribose, there is a hydroxyl group. In deoxyribose, so deoxy, one less oxygen. Instead of a hydroxyl group, it's just a hydrogen. So that is the difference between the two, ribose and deoxyribose. So ribose has an additional oxygen. So every nucleotide in the sequence has an additional oxygen if you're looking at RNA instead of DNA. And that oxygen is going to add a tiny bit of extra mass. So the answer here is RNA. RNA will have the greater mass, this one, because of the extra oxygen atoms. One per nucleotide.